Hello, all. Thank you so much for tuning in. This is Gregory Brennan, the Sustainable Transportation and Infrastructure Manager here at Virginia Clean Cities. For today's Technology Happy Hour, we have our anchor speaker, James Cooke, talking about data centers' energy use at the intersection of electrification. We'll be featuring other data center and electrification leaders. If you'd like to know more, please check out our website at vacleancities.org. And if you have any questions, please feel free to leave them below or email us directly. I have placed my email and along with everyone else's that presents on this call in the show notes below. With that, I will pass it over to James.
Hello, everyone. Welcome. And what we want to do is talk about energy and energy savings as relative to fleet electrification, which I've been a member of Virginia Clean Cities and a stakeholder for about 21 years. And we started our invitation with actually E85. If any of you ever heard of that, ethanol, 85% ethanol, 15% gasoline. And I worked with the Virginia Clean Cities as we migrated to the initial charge point units. And charge point level 1 is where we started. And when we found out that the electric cars can only go 20 or 30 miles and range anxiety set in, Virginia Clean Cities and the Manchester Group moved on to natural gas. And the natural gas was CNG and LNG, with a lot of the fleets that are in the area. Greg, the next slide, please. There is a turbulence going on with artificial intelligence and data centers. This particular slide is from a European company. That's why they spell data centers different from us. And the reason that we are talking about this with Gregory and Virginia Clean Cities is the electric vehicles are coming on, with level 3 with DC fast charger, but the data centers are eating up a lot of the power. I spent a lot of time over the last year with Dominion Energy, Duke Energy, and actually Exelon, all of them facing the ocean, the Atlantic Ocean, looking to bring in more power offshore. So one of our speakers today, Doug Hurst, will talk about wind energy. But the wind energy can't reach the data centers in the northern part of Virginia, which is Loudoun County. We call it Ashburn. It's not an actual city, but there are about 500 data centers there. And I went this summer with Dominion Energy trying to move their power lines from the Atlantic Ocean into Northern Virginia, where the dark fiber of the data centers are. And so they're upwards, so some people say 400. There may be 500 data centers. It's not exactly sure, but there certainly is a lot of data center activity there. And the communities are very concerned in all of the country, as well as what we call Virginia. Ashburn is the #1 data center focus in the whole world. And the problem that we have there is that there's not enough electric power. And your communities are concerned, and so is Duke Energy, as well as the Dominion Energy, to try to extend the power grid. There's been a lot of discussion of how the power grid can reach the data centers, but still provide the electric power that is necessary for housing. Enter AI. So AI is eating up a lot of power, and all over the country, there has been pushback. I've been to West Virginia. I know the governor of West Virginia likes to use the dark fiber that comes from Ashburn State, and they just don't know how they're going to put the energy in. The governor of Maryland is being very cautious. I met the Department of Commerce Director, Mr. James Cooke Jr., last week, and he talks about Frederick, Maryland, starting a data center. And Maryland would like to have data centers replace some of the lost revenue from the football team leaving, as well as other activity. So both Maryland, Virginia, and West Virginia, that trifecta of states, is trying to follow what Loudoun County and Ashburn is doing. But the biggest deficit is, where will the energy come from? So the electrification of everything is an article that I hope Greg will send out to everyone. But I just took a summary from that article. And this particular case, they're trying to figure out how to generate more power. We do know that Dominion Energy is considering 2 micro nuclear plants. And some of the later speakers will discuss how that could affect actually households and how we could generate more energy. So the question is, how does the electric vehicle and all the electrification, everyone has many, many electric utility things in their homes. Everything has become electric, but the data center and AI is sucking up all the power. Greg, could you go to the next slide, please? So we can share this with everyone later, whoever is interested. But this comes from Europe, and they're looking at how do we manage electrification of the households, the electric vehicles, the data centers, and all the time pushing towards a better use of AI. Some of the speakers later today will also tell you how we are concerned about robotics. There are places in Texas, which Mr. Lizzo could talk about later, that the robots are taking up a lot of their work at the data centers and elsewhere. So this whole thing of electrification with the batteries for the robots, electric vehicles, there's a conference in March that I hope to go to, and that's going to be for electrification of the airports. I was able to be at a BWI Airport, Baltimore Washington Thurgood Marshall Airport conference last week. I'm working with some people in Atlanta with Hartsfield Jackson, and the airports don't have enough plugs with the ground equipment becoming electrified. So a lot of the loaders of food and baggage is all electric. Many of the ports around the East Coast have electric used for equipment. Cranes and crane operators are becoming electric. So now we have this turbulence line: AI, data centers, and electrification of everything. We have to decide how to do that. One of the choices that Dominion Energy is considering is 2 micro nuclear. We don't know how that's going to work because many communities don't want to have nuclear in their neighborhood. So that's going to be a big problem as well. Greg, could you go to the next slide? So the electrification of vehicles, where the Virginia Clean Cities and I started to talk about, is now being pushed around by data centers and all of the AI from many of the companies. Many of you may know that Amazon 2 is in Arlington, Virginia. Amazon 1 is still, I believe, in Seattle. But Amazon 2 is here, and the power usage and AI, but Amazon alone is about a third of the usage in the data centers in Ashburn. There are several companies there that are also tenant organizations. So we'll talk about those later. And one more slide, Greg. So the one thing we can do, we can store that energy at the data centers. Lithium is being used, but lithium has some issues of fire. There's a company called Intel out of Dubai. We are connected with that company, and they're using graphene as their storage. In Japan and other areas, they're using magnesium to store energy. So that lithium, graphene, magnesium, and other precious metals can be used to have the battery energy storage systems to store energy, both either from the grid or from alternative microgrid. So next slide, please, Greg. There are case studies. This one doesn't have the images on it, but there was a case study where graphene was used by Intel for a 20 megawatt microgrid outside the U.S. and Yemen. We can see there the amount of energy that it generates and how it stores. Is that the future for our households in Ashburn and across the country as the energy is taken by the data centers? I don't have the answer. And the answer is something that maybe a microgrid that's going to come in with the wind turbine from Prosto Wind, maybe one part of the solution. There's also solar, there's geothermal, and then there's other sources of energy that would help with the communities as well as with the microgrid. And the next slide. We are members for over 20 years of the Virginia Clean Cities. I suggest that whatever state any of you are in, that you connect with your Clean Cities organization in the various states, because all of them are going to be challenged about the data centers that are being developed all over the country. California has a lot of data centers, not as many as Virginia, but California is almost like a country, and they have brownouts all the time. So everyone is going to be concerned about how data centers will affect the electrification of everything. We suggest that you get involved with your clean cities in every group, every state, and every one of those groups is trying to grow. The Department of Energy, it's no secret the Department of Energy is not giving these data centers a lot of notice, and they're not giving the Clean Cities organizations money. So as you can, please donate to your local Clean Cities organization and help them develop the brain trust and the knowledge to absorb the new data center activity. And I guess this is my last slide, Greg. We're proud to be a partner, and my email and phone number is there. So if you want to communicate with us, we want to continue to be supportive of the Virginia Clean Cities organization and the data center area. And I just wanted to have a small discussion here, Greg, and we go to our next speaker. And I believe, will that be Doug?
Hey Greg, hey all. Apologies for jumping a few minutes late. It's another stack day, so pleasure to meet you all. And well, I guess perfect timing. So, very quickly myself, just one second. I think Google Zoom has a bit of a lag in terms of video. So let me retry again. Hopefully you guys can see me shortly. But to kick things off, I'm a 15-year energy veteran, so really spent, electrical engineer by trade, and then really spent the first half of my career in the energy banking world. So intersection between energy finance. I was at Guggenheim Partners, JP Morgan, just to name a few, financing and deploying, battery storage assets to SMRs of the world for data center purposes, for commercial office buildings, and for, of the other back of the meter use cases. Next, I went, back to the industry. I joined and effectively built New York's first battery storage company called Perfect Power. So you may have heard of that, being backed by a middle market PE fund called SCR Capital Partners. We had a sister company called MGM, Microgrid Networks. I was a CFO for both companies, and managed $100 million P&L, but effectively helped bring online the first set of 10 megawatts battery storage for whole of New York. We were talking about 3 to 5 megawatts worth of sort of a smaller scale, working with Con Edison within its VITA program. And we were deploying, in Texas and California too. And, kind of a startup operator myself ever since early 2024. I've been starting to build out Brick. So hopefully that sets the stage for the broader context. Very quickly, Greg, if you wouldn't mind going to the next slide. Yeah, so essentially what Brick does at core, just to put it most straightforwardly, is that we are building a new advanced level operating system to manage all the built environment. When we are talking about commercial office buildings to hotels, to industrial manufacturing facilities, and finally data centers. So the status quo is that when we're talking about HVACs, right, it can be industrial chillers, it can be heat pumps, or VRF type HVACs within these buildings or facilities. They still run on a very much of a static level or on a set point basis. What that means is, these are the guys that effectively are still turning things on and off. They're still adjusting the set points. based on a single action of any occupants within the facility, or they are tweaking around different modes, but all of which are done manually, right? There's no automation involved, let alone more of an advanced control, controlling things more smartly based on the ever-changing environment, right? The outdoor temperature is ever-changing, the number of people within the facility is ever-changing. So whether that's an office building or a data center, our goal and the product underlying is that we have a software layer that's machine learning and reinforcement learning. Just to break it down, what that means is we have a simulation layer and we have an inference layer. Both in combination formulates this type of AI agent, which is just an overused concept, but this is an AI agent that effectively manages everything from HVACs to industrial chillers to heat pumps to even lighting, so on and so forth, in the most energy efficient manner, while still complying with the baseline hard set requirements. These operational requirements can be, right? We need to keep the ambient temperature within such and such degrees. So that's the software layer. And now, where does the software get the data? Right, that's where the hardware piece comes in. So imagine this is just a black box, kind of a universal gateway that can be bridged into any types of these energy systems via a simple two-way connection. We are only needing this one box connected to a master unit because of the connection that's already in place between the master units and the slave units, we are able to indirectly control the entire system. That's the idea. So again, hardware is the enabling layer, enabling the software to run it fully autonomously across data centers, buildings, and hotels, so on and so forth. Next slide, please. So very quickly talk about myself. I'm accompanied by Avinash, truly one of the most humble yet industry leading ML and RL researchers. He's got postdoc in automation deep learning. We're both accompanied by Nick and Tajay. So Tajay is ex-US Air Force and Honeywell. Nick is ex-Fidelity and Pinterest, etc. So boots on the ground, domain expertise, technical aptitude, and commercial leadership are really what the ideal team need to have to be able to really kind of address this issue in its entirety. Next slide, please. What you guys are looking at on this screen, right? Just to put all this in perspective, what does it look like visually? So this is our front end platform of our solution. So whether on the left hand side here, you guys are looking at a server flow of a data center, right? So imagine a couple of the pain points that the data center operators are dealing with on day-to-day basis. First of all, is there's effectively no visualization of sorts that's enabled on a software via a software format. Even with a traditional DCIM system, which is sort of a data center's own software operating system, even with the existence of such, the DCIM can only go as far as visualizing probably on the entire data center basis or of an entire floor basis. It doesn't really have the ability to go into every single server rack, be able to kind of visualize what is going on within each level of that server rack. So that's what sort of this blackish server rack on the right hand side of the snip is showing. We are able to show temperature, humidity, live energy consumption of every single level of the rack. And then we'll be able to do the color scheming, the slice and dice of reporting, everything being done so autonomously for data center client. On the right hand side here, right? What do our building clients care about? They want to see what is going on with their HVAC systems on the unit level, not just the entire system, right? We can't just turn the entire building on and off. We want to have unit level visibility and control. So again, same type of parameters that we are able to visualize. On the bottom here is the results of our fully autonomous energy saving agent. So in this case, one of the earliest pilot customers that we done was with one of the biggest local developers, real estate developers in Sydney, Australia. We actually unlocked up to 73% energy savings for them. On average, what we've been having to evidence out of all of our deployments is that on average, 15 to 20% in your actual utility bill savings, and up to 35%. Every single one of you is different. Every single one of the system is different, right? Obviously, the more inefficient the existing system is, the more savings we can unlock. But again, the genesis of all this is through an integrated hardware and software solution, we're able to do it all autonomously, generating energy savings while increasing comfort, decarbonize, whether it's for data center context or building context or industrial context. Next slide, please. just being well, I want to be mindful of the time. Even though I also came late to the slide. Yeah, so very straightforwardly, is skipping all the technicality, right? What you guys are looking at are sort of the outcomes, right? The results of our energy saving. For let's say commercial building client, this is the result I was talking about. Up to 73% actually in weekly energy savings. On the bottom right here, it's kind of a control screen that's internal to Brick. So every single client will have their own user view, which is on the previous slide. And then internally at Brick, we have obviously our own fully autonomous kind of, control screen that we can customize, we can stop it whenever that's needed. And all of which were really being done to allow for human intervention. So one of the key questions that you guys may have is, so how does it work, right? How does it be in sync? How is it in sync with any human interventions that if they ever want to do it? The answer is everything that's autonomous is catered or self-adapting to the human actions. If you guys feel like it's too hot within the office that you're sitting in, that's under the autonomous control of our agent, you guys want to tweak down the set point, feel free. You guys have all the freedom to tweak down the set point. But guess what? The model will discover that action and tweaking the energy savings rule accordingly. So if you guys tweak down the set points down, from 64 down to 62 Fahrenheit, all of a sudden the upper bound of one of the energy saving control strategies that we build in, the upper bound now becomes from 65.5 down to 63.5. So everything is designed to be self-adaptive, self-learning, based on human actions, interventions. Next slide, please. So very quickly, we've been working with the likes of JLL to, on the CRE side to hotel, for Hilton, DoubleTree Hilton to Sheraton for data center side. Again, I can't disclose fully yet, but it's one of the nation's largest, or also one of the world's largest data center developers. And then we're working with a channel partner here in the US as one of the biggest EPC providers that do modular manufacturing deployment for data centers and for commercial office buildings and hotels. So we are making quite a bit of a strides in the data center space, just given tons of activities. It is getting oversaturated, don't get me wrong, right? I think that's the aspect that we all know. But from a solutions provider perspective, there's a huge gap to be bridged. And then the pace is not slowing down whatsoever. So obviously, working with some of the partners, including James here, and some of the other folks, we want to make sure we can push forward with the right solution that sits on top of the existing system so that it's non-invasive and it's plug and play with the simplest integration method and be able to kind of deliver the immediate ROI with a minimum spend upfront. Our client payback period with the sort of the total energy savings you guys are seeing on this screen for this commercial office building, the payback period is as low as 2 to 3 months, meaning very minimum investment upfront. We even reimburse our client back for the money if we don't show any savings out of the pilot. So that's sort of the level of robustness and confidence that we have in trying to kind of working with all these industry leading players on energy optimizations, on increasing comfort and sustainability related initiatives too. Which next slide please. Which is truly of the utmost priority. So business model very quickly. We have a subscription model and we have upfront model. So both are tied to energy savings. So we don't Brick doesn't really make money until we generate savings for our clients. Just that simple. Next slide, please. Again, tech stack, I wouldn't go deep in the weeds here. So again, we collect the data via our hardware. We then facilitate the data to our model, which has all these underlying frameworks and algorithms. And then we formulate an autonomous agent, right? That can control HVAC to lighting to industrial equipment. And then we produce all these reports. Also, can benefit the clients with predictive maintenance so that they can effectively extend the useful life of their equipment too, which translates to millions of dollars, as a matter of fact. And then environmental protection as well. Next slide, please. Yeah, so we talk about the flow, right? So very streamlined. A lot of our clients today has been inbound. So they've heard about Brick, wanted to really try it out. We'll kick off a 4 to 6 week pilot, after which will be full deployment. So that's really kind of a streamlined process we have deployed across not just one single building, but really a portfolio of assets any of our clients have, whether it's data center developers, operators, or commercial real estate. Next slide, please. So yeah, so we did the same with one of the largest semi fabs in the world. It's actually so this one I can discuss with a global foundry. So gigantic manufacturing facilities, 24/7 fab that has this most stringent temperature or stability considerations or requirements. and they have tons of different protocols underlying. So it's really you need to have a universal gateway, right? That can sort of effectively integrate with all these different types of protocols, and being able to, integrate seamlessly so that you can start the work. A lot of cases, the industry, other folks that are in the same space are already stuck, even in the first phase, which the data aspect, the control aspect is extremely complicated. So you can really just rely on an existing system that's already making mistakes, that's already deficient to do the advanced level control. You really sort of need to bypass that existing layer, so that you can kind of achieve the optimization and automation in the most pain-free way. Next slide, please. So again, kind of a similar case study. I wouldn't go into deep here with Sheraton grant for the hotels. Next slide, please. So similarly with data center, it's about PUE optimization. So very quickly touching on it, whether it's about, tweaking leaving water set points to, managing the amount of cooling towers, or, in the case of air-based cooling, managing the fan speed, right? Managing the flow rate of the refrigerant for liquid cooling. We are controlling all these different key parameters to kind of realize energy optimization. So hopefully that gives you guys a kind of clear idea of what Brick focuses on. Happy to answer any questions you guys may have.
Sebastian, did you want to talk anything about your appendices or
Oh yeah, great point. Thanks, Greg. So apologies for my video. It's still loading for some reason. So Zoom is not doing me a favor today. But for the last two slides, this is actually the industrial AI offering that we have. So put it simply, we have besides our MLRL agent, we have a computer vision model too. The use case is as simple as if we're working with Lucid Motors of the world, for example, a gigantic EV auto manufacturing facility. They're not only worrying about energy optimization. They might be worrying about, okay, how do we manage regulatory risks? How do we manage safety risks and compliance risks? So if you think about it, it's really about, coming up with a building on a top of a CV model. Next slide, please, Greg. Building on a CV model so that you can effectively use the hardware such as cameras and lidars to kind of spot the motions and poses of these different people within manufacturing facility or across any other use cases, so that we can kind of preempt worker actions, compliance behaviors that are sort of out of whack, so that we save people money, we save people from potential risks, and again, this is sort of a natural value extension of what we do at Brick2. That's it.
All right. Thank you, Greg, and thanks everybody for joining. Sebastian was kind enough to give us the insight to the inside of the data centers. I'm here to talk to you about the power required and the power available to run those data centers. So basically, I pulled some facts off the internet. All right. The average power draw for the data centers are in 5 to 20 megawatts. Obviously, that depends on their size and the density of the equipment. There's a growing requirement for clean power, which means to reduce their carbon emissions and use green energy. And lastly, and probably most importantly, is the high quality power that is essential for data centers to protect their equipment and their operational efficiency. So, what we have is some needs that we need to talk about and some possible solutions. The first thing you need to do is continuously monitor the electrical incoming power for quality and how it's integrated into, for instance, Sebastian's system, so that we can make sure that we get real-time, instantaneous data to react or predict when may occur or adjustments need to be made. A renewable energy system is resolution to number two, which is the clean part of it. But in order for renewable energy to work, you need a combination of renewable energy sources and battery storage. No one energy source can be stable enough and constant enough, even with batteries, to maintain the power requirements for any microgrid. And last, the renewable energy size needs to be sized upon the historical data and then be maintained and upgraded every year so that you know what increments need to be done to keep that data center up and operational or to grow. So let's understand the requirements. We talked about in the first slide megawatts, which is a capacity. Okay. Megawatts is not what's consumed by the data centers or any load. What's actually consumed by them is kilowatt hours. So what I provide here is a typical calculation for instance, in a solar field, for a 1 megawatt solar field, how many kilowatt hours can that generate a year on average? Now that's on average, okay? Keep in mind that that's only when the sun shines, and that's only if there's batteries that are 3 times the available of the sources that are needed. So for a 1 megawatt, if you were going to install solar for a 1 megawatt capacity, you would actually need to install up to 3 megawatts of solar along with a huge amount of battery storage to maintain power 24/7. So what we've done here is just analyzed, let's say you have solar with battery, just a 1 megawatt solar field by itself. Average cost of the solar field, 1.8 million. Battery storage at a half a million per megawatt. That would require an investment of 6.9 million. So the electrical output of that, over its 20-year life, you would realize a cost estimate of about 60 cents per kilowatt hour. That's expensive. You'd also need about 15 acres of land. All right. And if I was going to analyze a typical wind power system, it would be very similar to this. You have to have a constant output out of your energy source, and you have a variable input, which makes it difficult. So what we've had here is taken a technology, and oh, by the way, I am an electrical engineer and been in the field for I don't know how long, too long probably. Um, we have a new solar panel that can get to about 32% efficiency. It also produces electricity in low light condition. Taken into a typical 1 megawatt solar field, our output is about twice as high as what it is for traditional. If I add in our unique vertical wind power, operates over a much wider range of collecting wind energy and converting it to electrical energy, at a low level, so it's not obtrusive to the environment. It also is quiet and doesn't kill birds, but its output is almost 3 times that of a same size solar field. However, the wind doesn't blow all the time when the sun shines, and vice versa. And in fact, in most locations, you'll find that when the wind blows, the PV generation is low, and vice versa. So they're inversely proportional. And if I was going to use a battery storage with this combined renewable energy source, it would be about 25% of what was needed in a singular 1 megawatt solar field or typical wind farm. This allows the power plant, which is what we're doing here of providing power to a microgrid for large battery installations and potentially adds revenue with sales back to the grid versus you paying what is growing to be a very high price for electricity in kilowatt hours. So what you see here is a typical 3 tower stack of wind power. And if I do an analysis for the same energy here of 1 megawatt for wind, solar, and approximately a quarter or 25% of the battery, we meet the power requirements for the 1 megawatt example of 500 and nearly 580 kilowatt hours a year, but we also are going to put out about 4 million more kilowatt hours. Now, what that'll do is that'll leave you room for expansion, for downtime, or to sell back to the grid, which is another revenue source, which would probably be welcome in most of these cases. Total cost of about $4.8 million over the life of the equipment would be about 5 cents per kilowatt hour. That is much more realistic for what you would want to see. And additionally, as I said, it could be about $4 million in revenue generated over those 20 years by selling back to the grid. What we've also developed is what we call our smart cable devices. We actually place these, the left-hand side of this is a football. It looks like a clamshell, clamps on a power line. It measures all the attributes of the power line, including voltage, which is its breakthrough renovation. So it communicates wirelessly back to a user interface, and that can be integrated, for instance, with Sebastian's system. So you would know the incoming and you would know the usage and pair them up. I'll tell you now that the microgrids that we've done so far and the grids that we've done so far are showing a great deal of instability, specifically in power factor and harmonics. And as electrification of the power grid becomes more and more forthcoming, those type of loads, those nonlinear loads that cause those problems, are only increasing. With that, there will be ultimately, as alluded to before, brownouts coming and then eventually blackouts. This piece of equipment here, when clamped on a power line, can can provide you information so that you can make adjustments at the grid level to sustain your energy and not having those rolling brownouts and blackouts. Each one of these devices, whether it be solar or wind combinations that were stipulated in the microgrid, have these integrated into them. But more importantly, when we have grid power, we're going to monitor that too. Grid power is not to the point, they don't measure power quality, guys. So there's a significant issue there for them. So in conclusion, we're going to want to address the energy needs of the data center so that it has always stable, clean energy and hopefully renewable energy. Today, grids operations cannot provide that solutions, and you can see that the costs are going up, and you're getting public pushback from the residents where you want to build your data centers because of this, because of the cost of the electricity rise. By integrating the multiple clean energy sources, and they may not be wind and they may be solar, there may be other renewable energy sources to provide power to that microgrid. The power management and sustainability of your electrical costs now become under your control and adaptable. With that, I think that thank everybody for their time. And Gregory, you can move on, I think.
Thank you so much, Doug. Oh,
Yes, I'm sorry.
you're good. You're good. I just want to make sure we didn't lose you.
Yeah, nope, I didn't. So, good afternoon, everyone. My name's Lisco Scott. I'm the Chief Operations Officer for Complete Systems Integrators. I what I would like to do, I have my Chief Technology Officer on the line. In this call, I'm going to have him speak to our slide deck, and then I'm going to speak to some of the other, I guess, concerns which could potentially lead to a Q&A at the end of this around data centers, AI, and and where this country is heading in regards to supporting that and being able to support that. Um, Mafu Shabazz, he's our Chief Technology Officer, and I just want to hand it over to him at this time. Mafu.
Can do. Yeah. Thank you.
Yes, we can hear you.
Excellent. I appreciate everyone being here. Thank you for giving us the time. I've spent maybe past 15, 20 years helping from Fortune 500 to small business owners and stakeholders figure out how they manage risk within emerging tech. And right now, as per our discussion, right, data centers, AI, and the sort, AI is really the emerging tech that we're focused on. How it impacts data centers, what our perspective is around some of the challenges that are being faced by communities and so forth is the topic of this conversation. So our perspective is that we're witnessing a collision where AI growth really is sort of meeting the great constraints. And as has been discussed in some of the other conversations earlier today, if you take a look at what's happening on the data center side, right, you have consumption, massive consumption, about 5 to 20 megawatts per facility, depending on the size of the facility. AI has really accelerated the build out. Now whether we're actually sitting in the bubble or not is another interesting conversation we can have another time. But for now, everyone's pouring money into the promise of AI. So it's accelerating. And as a result, we have some constrained grid systems and rising infrastructure costs. On the community side, what we're seeing in the conversations that we're having with our clients and community stakeholders, you have escalating electricity costs, and that's been discussed in other conversations today. the same grid strain, which now, causes reliability concerns for homeowners, competition with homes. Now, Loudoun County, the whole Ashburn, Herndon area is expanding at a tremendous rate. But if you look at other parts of the country, and everywhere that's a good place to live, where people want to move, where there's adequate grid infrastructure and water, everybody wants to live there, and those areas are expanding rapidly. They're also coincidentally the same places that make good sense for data centers. So there's a competition there. And we're now seeing across the country stakeholder resistance, right? Community boards, community leaders are standing up and saying, we don't want these data centers here, or we have to figure out another solution. So the current approach is build more infrastructure, add more power capacity, and then what happens is stakeholders end up getting engaged too late. We consistently see this over and over again. Community leaders saying, listen, nobody talked to us about this. We didn't even know this was going to happen. Agreements were made somewhere above our layer. And now we have to deal with another data center and the noise and the other challenges. The missed opportunity from our perspective is that if you took the time to optimize the demand first, kind of really understood what that looked like, and then you took the time to structure the energy partnerships so that there wasn't an impact, you could then capture some shared value early. And I'll talk a little bit more about what that value looks like, right? From our perspective, communities and stakeholders are actually leaving value on the table by not engaging early enough with data center operators and builders. So the cost of business as usual, what does that mean? Right? So if you have infrastructure over expansion, where you're adding power, you're not really optimizing demand increases, capital requirements, and you're straining the existing system, and you end up with community resistance, right? The late stakeholder engagement I discussed earlier creates opposition, delays, regulatory barriers. The lost value means that you have missed opportunities for cost reduction, revenue sharing, and grid reliability improvements, which are necessary. We don't see a lot of revenue being poured into grid upgrade or overhaul today, but it's going to have to happen. As alluded to earlier, if we don't, we're going to start seeing brownouts, all of the issues that impact not only the grids, but really impact communities, and that will only increase community resistance. Next slide, Greg. We're proposing a slightly better model, right? And whether it's truly better or not will depend over the long term. But from what we're seeing, where there's some examples or some initial examples, it looks like this could be a better model where you take the time to optimize, align, and then monetize. And optimization means that, yes, we're going to be using AI. We're going to be using AI to drive energy optimization, like things like what the BRICS team is working on, reducing that load, right? 15 to 35% before infrastructure expansion. And we've actually seen that. And I think at least two teams on this call can actually validate that. Align, what does that mean? So you integrate data centers with renewables and microgrids to improve reliability and reduce costs, right? Monetize. Now you can structure partnerships that enable lower costs and new revenue streams for all stakeholders. There's a lot of money being left on the table, and it's going to take a new model to kind of be able to maximize that. And I think when communities start to see that there's some benefit for them and there's a reduction in the harms that are being caused, then you start to have that participation. Everybody makes money. Next slide, Greg. So our approach, we call this specialized execution. And people ask us, say, hey, what do you guys really do? Right? You sound like an advisory firm. And yes, most of us have a background in Big 4, Big 10, whatever. And so we do have that. But we also have a lot of history in actually doing the work. Been there, done that. We have that real world execution, right? Not just strategy. One of the things that we saw consistently and that really drove kind of refining our practice approach was that for most large projects, or every single one of these large data center projects, you're going to have a large consultancy engaged. They have the breadth and the width to handle large scale project execution, project management, And 9 times out of 10, they're involved in developing the strategy. Where they tend to, what we've seen, they tend to maybe have a gap is in actually figuring out how to handle and track across the lifetime of that project, and the life cycle of the project, the real world execution of that strategy. And so that's kind of where we position ourselves. So yes, we're consultants, but we're also practitioners who built and operated these systems. We have the deep background in doing that. And our focus is that if you make AI infrastructure growth work for communities and not just happen to them, that's when you see the kind of outcomes that communities and data center clients are looking for. So the path forward. It's a short presentation. The goal isn't just to support AI growth, right? It's to structure so communities benefit economically and not just absorb the cost. I think if you were to drive around and talk to community leaders across Loudoun County, especially, just because of the density of data centers in the area, you would hear a lot about how communities are absorbing the cost, right? And questions about what can we do about it. And I'll pause for a minute, one, to see if there are any questions, but this piece I'll let Mr. Scott take over.
Yes, I'm here. So thank you, Mafu, for that. And again, so ComSys, Complete Systems Integrators. Um, ComSys has been around now it'd be since 2000, so 25, soon to be 26 years. Um, it's a service disabled vet small business trusted across federal, state, and enterprise. We've done work for a lot of work for the DoD, U.S. Army, Marines, Air Force, as well as Hartsfield International Airport, MARTA, just to name a few in terms of our clients. And, our 20 years of delivering across, mission critical systems, data centers, infrastructure, cloud, security, networking, intelligence systems, energy management, just to name a few. In regards to my background, I'm a 30-year veteran, 25 years of that, 10 years of that working for a global bank, Barclays PLC, 25 years of that working in oil and gas and managing data centers. So as Mafu, Mr. Shabazz stated, not only are we can offer consultancy services, but we are practitioners. We've had our sleeves up and we've done the work and we see the challenges. And we talk about internally in regards to, which was discussed earlier, all of the concerns. There's major concerns in regards to this country with the evolution of AI. AI has been around for a long time. It's not like it's really something new. The only difference about AI today is it's on steroids, therefore requiring the demands to support that in terms of turning up these data centers. I want to use Texas as an example because that's where my residence is at, even though I travel a lot. Here in Texas, Elon Musk, as most of you all may be aware of, he moved his headquarters from California to Austin, Texas, as an example. And Elon has built and is building AI data centers like crazy. The problem with Texas is all of Texas is not on the national power grid. Only Austin and El Paso is. And the rest of the state is on this independent power grid, and that's being managed by ERCOT. The problem with that is, as was previously stated by multiple people, here in Texas, we experience a lot of brownouts and blackouts. And we experienced them at the times where we needed the most, like during the winter months or during the summer months when it's extremely hot. So, you know, the challenge is, what do we do as we move forward in our specialized industries to, bridge that gap, pull the right people together to ensure that we have stakeholder buy-in at the community level, at the state level, and the local municipality level as these data centers are coming more and more to fruition. In addition to the fact that, as these data centers are being built or retrofitted, existing data centers still have to run in parallel. So it's not like, you're shutting one down and turning one up necessarily. You have existing data center infrastructure that's being supported while the new AI data centers are being turned up so where they could be transitioned to. So, um, I appreciate what I've heard today. It's evident to me that, there's a lot of work that's going on, especially in the Virginia area. We know that area very well. CompSys does. We had offices there and, look forward to the opportunity of working together and further collaboration with Virginia Clean Energy in order to, help progress some things. Clean City to help progress some things.
Thank you again for tuning in to today's Technology Happy Hour. If you've made it this far, thank you. And if you'd like to know more about Virginia Clean Cities, please click on the links below in the description. We hope to see you on a Technology Happy Hour soon.